David Smith here with one more Flip Classroom Math video. 3 tips before we start. Remember, you can slow down or speed up the playback at any point in time if that helps you consume the video. Second, remember that you can pause the video at any point in time and catch up on your notes. Third, remember to turn on the captions if you want to watch my words go by on the bottom of your screen. Today's lesson covers problem solving, specifically how to use points of intersection between two functions to answer the problem that's posed. So check this out. We're doing, this is a classic physics type problem. We're going to throw a ball in the air, and that ball is going to have a path given by f of t is 1.75 plus 0.75 t minus 0.0625 t squared. Lots of decimals in this thing, but the truth is we are just going to put it in the calculator and use the calculator to figure things out. We're not going to solve this one. This problem could be done algebraically, but it would be a pain. That's why we have the fancy schmancy calculator. So let's take a look at our function just to make sure we're all set with our variables. T is the time in seconds, and f of t is the ball's height in meters. Okay, so we're not talking about the distance the ball has traveled, we're talking about the height the ball has traveled. Okay, so we're going to do 3 things here, okay? 2 of them don't involve intersections, but it's part of this problem, so it's good that we do that. You might get asked questions like that in the context of this problem. So the first one, find the ball's height after 5 seconds. So how is it 5 seconds into its flight? Second is find the times when the ball's height is 3 meters. And this is where we're going to do our intersection to find the solution to this one. Finally, the last one is find the time when the ball hits the ground. So hopefully your mind is already churning away on ways that we would solve this problem. Okay, here's that first question. I reproduced our function up here just for reference. Find the ball's height at 5 seconds. Go ahead, pause the video, do that calc, tell me what you got. All right, here's what I get. I went ahead and showed you the plug-in step. F of 5 is 1.75 plus 0.75 times 5 minus 0.0625 times 5 squared. When I do those numbers, this is what I get, 3.94 meters. So that's how high our ball is at 5 seconds. All right, let's take a look at the B part of this word problem. When is the ball 3 meters high? Now, I want you to think for a sec. How many times in its path is the ball 3 meters high? If you said twice, you're right, because the ball is thrown. This is the y-intercept of our function. The ball is thrown and released at 1.75 meters high. That's kind of just about right. Someone throws it like that. If I'm 2 meters, this is 1.75, and it's going to go up. And it's going to pass 3.9 meters, because that's where it was at 5 seconds, but eventually gravity's going to pull it back down, and it's going to pass through that 3 meter mark again. So it's going to hit that height twice in its parabolic arc. Now, we're going to find this through intersections. And we have 2 functions that we're going to graph and find their intersections. Here's our function. Now, this is a nice big critical thinking step leap, but I'm going to ask you to give it a shot. What function represents the height, represents the intersection when this function crosses that 3 meter line? Okay, here it is. I'm going to give it the letter G of t equals 3. Okay? So, interestingly enough, it doesn't depend on time. This function is just the horizontal line going through 3. Okay? So, now let's take a look at a graph. I'm just going to do a rough graph here. Here's our ball's path, like that, with x there and y there. And here is our height. That's our g of t equals 3. And this would be our f of t equals this big long function that I'm not going to write again. So the ball gets thrown. Here's its parabolic path, flies through the air, hits the ground. It's going to pass through this height of 3 meters twice, and that's going to give us our t1, our first time, and our t2, which is our second time. And this would be a height of 3. This would also be the max height, and I may ask you to find that just a little later. Okay, here's what I want you to do next. I want you to get out your calculator, and I want you to put these two functions in your calculator so they show up on the same graph. And if you don't want to write f of t, you could just put y equals there, and this one you could put y equals. Either way is fine. You should end up with a horizontal line at 3, and you should end up with a parabola that rises and crosses 3 and then drops back down across the 3 line. If you get those two graphs done, then use the trace function to find the coordinates of those two intersection points. So go ahead, pause that video, get out your calculator. If you need to review the instructions for how to throw graphs in there and use the trace to find points of intersection, do that. You're gonna need to do that in the exercises. Okay, when I go into my graph, here's what I get. This is just a sketch. It's not super accurate, but it certainly conveys what your graph and your calculator should be showing you. So again, here is my parabolic path of the ball. Here is my horizontal g of t equals 3 line. And here are my 2 points of intersection. I trace them off the graph, and I get this one comes at 2 seconds. So that's the point 2, 3. And then this one comes at 10 seconds, which is the point 10, 3. Now your calculator is not going to show you units. It's not going to say that that's meters and that's time and that's height, but it will give you these points. So you should be able to do that with your calculator. Now I want to ask you to find this time. This is our C question, which was when does the ball hit the ground? Let's put that over here. When hit ground. Now, you might want a hint for that. Find the zeros of the function. You'll find one that's back here. Mathematically, that's totally 100% fine. The problem with that in reality is that happens at a time before we threw it, which doesn't make sense. The ball wasn't traveling up from the ground to the hand and then thrown. It started there. So that 0 isn't going to make any sense, that x-intercept. But this x-intercept is going to be the one you're after. So go ahead, find that 0 of this function and come back and tell me what you got. So this one happens at 14 seconds. That's the total time that this ball traveled through the air to hit the ground. So that's the last thing. Now I did hint that I would ask you to find the maximum height. So go ahead and do that. Use your trace function to find a max. All right, when I go into my calculator and trace and find out the maximum, I get the maximum happens at 6 seconds and it's 4 meters tall. So we can pretty much describe a lot of things about the path of this ball using the fancy calculator to do the lifting for us. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. You can also watch the video again if you need to deepen your understanding. If you enjoyed the experience, please click like or subscribe.